I'm Matt.
I'm Zach.
And we're Team Bravo with Citizen Science for Cancer. So, what is cancer? Well, cancer is basically when a bunch of cells won't stop dividing because their DNA is corrupted. How do you treat it? Well, usually normal therapy works by just stopping all cells from dividing. And it works, sometimes somewhat, with a bunch of nasty side effects, generally not a very delightful experience at all. So how about instead, we just target all the cancerous cells and get them to stop dividing. Except the problem is there are hundreds of different types of cancer, with causes ranging from viruses to radiation. They all act differently. Basically, you can't target cancer. Okay, let's target all of them individually. Let's create a bunch of therapies targeted for each molecular type of cancer, find out what type of cancer a person has, and target it towards that. So the problem is, how do we tell what type of cancer we're dealing with? It turns out, most of the time, a particular cancer will have a particular set of idiosyncratic mutations which will determine what type of cancer it is. Things like symptoms and the location of the cancer are actually irrelevant. So how do you go about that? You first have to construct a database and research therapies for all the different types of cancer. Can't really get around that. But to do that first, you need to be able to identify the cancer, like I said. How do you identify the idiosyncratic mutations for a particular type of cancer? Turns out what you have to do is you have to get a bunch of cancer patients, take samples of their healthy DNA, take samples of their cancer DNA, take the difference between the two, and you've got all the mutations, right? Bob's your uncle. You can just go ahead and start your therapies now. Except actually, no, because normal cells mutate too, and the DNA sequencing technologies that we have right now aren't very reliable. Actually, when you do this, only about 1 in 1,000 mutations that you detect are actual real cancer mutations that are worth researchers' time to work on. So that's where our project comes in. It's called Carcinosh, which is Greek for cancer. The domain is free, so we picked that name. Basically employs people that, with spare time in their hands, to vote on whether a particular mutation is cancerous or not. We aggregate the results and we export them out to let researchers know what to focus on.
So here's a visualization from our application. Above you can see that healthy genome and below the cancerous one. Left to right is running our DNA positions, and each individual sample of that DNA is stacked on top of each other. Firstly, you notice some interesting things. So there's noise in the data. This is just from random mutations in cells, or it's from bad reads from a sequencing machine. But there are also these interesting points, these vertical points, where individual references are clearly mutated. This here would not be a cancerous mutation, because the same mutation is present in the healthy and the non-healthy cells. However, this is. You can see that, yeah, there's a clear signal in the cancerous mutation, but that signal is not there in the healthy. So our aim was to make a website where the average user can go on this website and, help. They can go on the website and check that this is and help.
Yeah, our goals were basically to create a website where people could go on, learn about different characteristics, and have an easy way to vote on these different mutations, or whether they're mutations or not, and obviously exported it in a useful format. So how we actually did this was, on the front end, we just basically have a simple JavaScript SPA written in ES6 with React Redux. Renders the sample out into DOM elements, not very performant, but fast for prototyping, send responses back to the server, which is a simple Java backend, using the Spark Java framework, communicates with the front end with a JSON-based API, using a Postgres database, also hosted on Amazon. The actual big challenge in the project was working with the different formats. Turns out that this is a very niche problem. There are no open source solutions that readily let you just import this data. We had to do some code spelunking into C tools written by biologists. Wasn't a very pleasant experience. Lessons learned, get a domain expert to help you straight away. We find our client very helpful for this. So that's the domain. Feel free to visit it. We probably have lots of bugs and exploits. Feel free to crash our server. It's a free Amazon instance, so we don't care. And thank you.